All right, so we're going to look at the mean of a linear function of a random variable. So that's a mouthful in itself, but first we're going to look at what's called discrete random variables. And so just to remind us what a discrete random variable is, if we just think about the words, discrete meaning we take on sort of discrete chunks. I know that sounds circular, but we're taking on values that sort of step. We can't have anything, so say between 1 and 2, you can't have anything in between 1 and 2. Classic example of something that's discrete data would be shoe size. You're either a size 7 or a size 8. Yes, you can be 8.5, but that's discrete. Your shoe size cannot take on values in between the shoe sizes that they sell. However, something like your foot length would be continuous because you could have a whole range of foot lengths in between, say, 20 centimeters and 21 centimeters. You could be anywhere in between there. So anyway, that's just the idea of discrete. And so what we're looking at is the mean or the average of a linear function of a discrete random variable. So I think the only way to really explain this properly is with an example. So let's just jump into it and it should make sense. So let's imagine that this capital X, or this discrete random variable we're calling X, is the number of emails that someone receives in a day. And it's a slow day or it's a slow week, and it's a slow day, so they either get 0, 1 or 2, and we are going to assign probabilities to those things. So the probability that the person gets 0 emails is 0.2. The probability that they get 1 email is 0.5, and the probability that they get 2 emails is 0.3. You can see that there's no other options there because 0.2 plus 0.5 plus 0.3 is equal to 1, and so all possibilities are covered there. They can't get any more emails than a maximum of 2. And so what we can say is, well, how do we find the mean of that? How many emails would we expect to receive on average in a day? And this is the formula, and this is what's called the expected value, or the mean, or the average. And so that we say E of X is equal to the sum of lowercase x from sum of all the x values. Now the lowercase x values are these ones, so 0, 1 and 2, multiplied by those probabilities. Now it sounds complicated and it looks a bit complicated, but all it means is you multiply 0 times 0.2, then you add on, because it's the sum, 1 times 0.5, and then 2 times 0.3. So you'll get that. I encourage you to really think about why that's the case. I've probably explained it somewhere else, but encourage you to think about why that gives you the average, and when this would be a good example of a time where you could try that sort of simplifying. Think of a simpler problem where you could really start to get a feel for why that's true. In any case, this term goes to 0, this is 0.5, and this is 0.6, so that gives us an expected value of 1.1. So this person is going to expect to get 1.1 emails on average in a day. And then now what we're doing is we're going to do this linear function of a random variable. So now we're going to apply this sort of transformation in some sense, and let me show you what that looks like in terms of this example. So let's say, for whatever reason, that these emails take 5 minutes to write, plus 10 minutes of fixed admin time. Now, I don't know what kind of emails they're writing, but let's just imagine every email takes 10 minutes for some wacky administrative reason. That's additional. So you can see this is a kind of a linear function, right? 5 times the number of emails plus 10. So the question is, how do we find the mean of that linear function of this random variable? So let's look at what that looks like. We're talking about another random variable, which we're going to call y. So the expected value of y is now the expected value of 5x plus 10, because remember, x is our discrete random variable. And what we're sort of doing here is we can sort of break it up. We can say, all right, the expected value down here was x times the probability of x equaling lowercase x. So here we just take this out the front. So it's 5x plus 10 multiplied by the probability that the random variable takes on a specific x value. Okay, and that should make sense, right? Well, it'll make more sense in a minute. Let's just step through it. So what you can do is you can take the 5 out the front and you can separate this. This is a property of sums, which probably don't have time to go into here, but a property of sums is you can sort of separate things out like this. Don't stress too much about it, but just take my word for it that is a valid line of reasoning. And so you can see that this sum, this part here, is just this part, is just the expected value of x. So it's 5 times the expected value of x plus 10. So just doing some detective work here, that must mean that this part is equal to 1. And that should make sense, right? It's the sum of all it's the sum of all the probabilities is basically all that's saying. The sum of all the probabilities, so that's just 0.2 plus 0.5 plus 0.3, which is 1. So this term here, or this part here, I should say, goes to 1, so you're just left with 10. So the expected value of a linear function of a random variable is 5 times the expected value of the sort of random variable without the linear transformation plus whatever that constant is. Anyway, maybe I'm over-explaining it, I don't really know, but if you just apply that function now, you can say that it's 5 times 1.1 because the expected value x is 1.1 plus 10. So on average, in a day, a person can expect to spend 15.5 minutes writing an email. So that's it. Let me show you a picture because it wouldn't really be complete without a picture. So let's have a look at what a graph of this might look like. Here's the distribution of x. So this is the number of emails they get per day. There was only 3 options, right? They got 0 emails, which had a probability of 0.2. So I haven't got numbers on the y-axis here, but 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and so on. So the probability they got no emails is 0.2. The probability they got 1 email was 0.5, and probability of 2 emails was 0.3. And so we worked out that the expected value of that was 1.1. So that would sit there. And similarly, the distribution of y, so the distribution of how long it took for them to write emails, well, if they got no emails, it was going to take 10 minutes. If they got 1 email, it would take 15 minutes because it's 5 times 1 plus 10, which is 15. And if they got 2 emails, it'd be 5 times 2 plus 10, which is 20. So this is the distribution of the number of minutes it's going to take them to respond or to write their emails. And finally, again, we know the expected value of that distribution now is 15.5. So that's right in that line there. Okay, so that's how you work out the mean of a linear function of a random variable. Hopefully you found that useful. Give us a thumbs up if you did. Good luck with all your studies. I'll see you soon.